Hello everybody, welcome back to McKinley. Here we've got so many items of stock and points and signals and things that we need a database to help run our railway. I can hear you guys thinking, a database to run a railway? Well, for the nerds amongst you, here's why. Come and have a look. The Digitrax world has an amazing feature that I don't know where it was, but it's always been in there. And what it is the command station sends out triggers across Loconet to provoke all devices that report statuses to report it back to the command station. And it does this by means of a series of 8 instructions. And what we've done here is we've triggered a GP on without any of the network connected to show you as it sends out the instructions one after the other, which is 8 switch instructions. There are 4 of them to one direction and 4 of them, the same 4, in the opposite direction. So switches 10, 17, 18, 19 and 20 are closed and then they're sent out in throw. And that provokes all of the devices on the McKinley Railway to report their statuses. So the first video there shows just those commands being sent out. The second screen shows the same sequences being sent out, but this time being connected to the Loconet of the extension. And you'll see the GP on message flickering up briefly on the screen. Forget the unknown packet stuff. And then just a stream of data starts surging out from all the devices connected to Loconet. Hundreds and hundreds and hundreds of messages. We typically get somewhere in the region of about 1,500 to 2,000 messages being sent out. The devices are all recording their states. You'll notice on this particular dump, it appears to pause. That's because we haven't finely tuned some of the hardware to be a bit more shall we say, crowd friendly. So some of the hardware is hogging the reporting, and this will improve in time. But it shows you all that raw data that's being sent over Loconet, which up to now no one sees. But once we plug the database into it, we're capturing all of that information and then sucking it into the database API. And that is the bit that gives us the power to see the state of the layout at startup. The other bit that's really important is that this API stays connected during the operating session, so it sees every throttle change, it sees every point change, it sees everything. So it captures in real time the data that's coming over Loconet. So the database has a real-time picture of the railway. So it's not just train control that knows about it. We now have a database system that keeps track of it. And when you start adding in the other stuff like RFID, well, we're streets ahead. The FM interface has sucked in all that data that gets spewed out after the GP on and the 8 switch instructions over Loconet. The 1,600 messages that get spewed out from all the devices. It's all captured in FM interface, which is interfacing with the database, and it presents us with a diagnostic tool for allow us to check how things are going. So in our current version of the layout, we're expecting 640 sensors to report, 183 switches and 60 signals, and you can see that we didn't hit any of those, and maybe we can go and explore to find out. And this is the power of what we have built to allow me and the other operators or the system administrators of the railway to go in and see what is and isn't happening. If we scroll down here, you can see that the software kindly highlights in red where things are missing. So board 147 has got no reported sensors. It was expecting 16. We can go into the database, and I'll show you in a minute how we can interrogate the database to find out what that means. Further on down, board 160 was missing 16, and board 171 should have sent 2 out and didn't. there's a further 4 boards here that haven't reported what we expected them to. So we're in developmental phase right now. If I was operational, I might be worried about this, but right now I'm expecting these kind of things. The same situation with switches. There is a maximum of 2,048 switches on the railway. That's the Digitrax limit. We're expecting 183 to report. We've got 169. If we click this open here, we can see that this DAC20 board here with the switch numbers 179 and onwards didn't report at startup, and nor did switch numbers the board with the 8 switches or points starting with address number 171. And so this allows us to see very quickly how things are going very well or not. The other thing is the signals. This looks dramatic, but actually we've unplugged this board, so those 3 were expected. But these other ones are certainly something we need to go and look at. And what I'm going to show you is now the tables in the database, if you look at it from a FileMaker's perspective, where we can go in and look, where are these problems? So that's that API there. Over to the database. It's the McKinley Railway Database Administration menu. Our normal operators do not see it, but it's there for Ian and me and all the other techies in our team. The key things to look at here, I'm going to take you through some of the key database areas that you will have seen when we scan the data coming in over LocalNet. The first one to have a look at is sensors. Let's go and look in here. I'm going to select all the records. There are 4,096 potential sensors on any Digitrax-based railway. That's it. You could have 2 LocalNets and double it. We've created a record for every potential sensor, whether we've got it active on the railway or not, which is why there are 4,000 records. But let's go and search for some useful records. Let's go and find the block detector records. Here you will see up the top there 502 block detector records. Most of them will be linked to a BDL 168, so they're in groups of 16. And on this it tells you its logical address, the name we've assigned it to, where the PCB board is associated with it, what it does, which block it is associated with, whether it's on or off right now, but that might not be accurate because we're not running it live at the minute, but it's last reported time, and whether it's reportable or not. If we go and refine, search for reportable to be yes. Go more like a digital version of 1. You can see that right now we're running the railway where we expect to see 291 records. Let's go and have a look at what the other sensors are. If I find and go through the list here, the dot detectors. Again, those are the infrared detectors that we use for stopping trains. On this railway there are 336 records. Not all of them are active at the moment because we're not running the old layout. Let's go and search for the cousins of the dots, which are the DAS records. They are similar to dots. We use them in a similar way. They were to be used originally for another purpose, but that didn't work out. There are 79 of those. The other really important thing to just show you is the scheduled triggers. They're not an operational device nor a physical sensor on the layout. What the database is using these scheduled triggers to do is to provoke Train Controller to run a specific schedule. So if we look at this, you can see if I go into this particular one, this is sensor 3272. We won't be expecting to see that sensor come from the railway, but the database will send that out over LocalNet. Train Controller will see it. Train Controller then has an action to run the schedule London Platform 1 to Birmingham North via the red staging yard. So that shows you what those things are about, and that gives you a quick picture of all the sensors on the database. To share with you is switches. Here there are 2,048 potential switch addresses on any Digitrax layout. Let's go and find out how many points we've got on our railway. If we look for points here, you can see that we have 379 points, and I don't think that includes the points for Halifax and Wakefield yet, does it, Ian? Nope, he's shaking his head. So it's going to go to over 400, 450. Another key physical switch logic we use for is carriage lighting. Each of our coach sets has a reserved switch address to be sent out to turn the carriage set lighting on and off. Each carriage set has a carriage set number, and we've reserved the switches from 1 to 99 for this purpose. We're using these as a temporary test with DS64, so we'll ignore those. Let's go and have a look at what else we've got on here. The lights on the layout. By the way, this interrogate, this is those 4 switches that you see the command station send out that triggers all of those messages to come back on the GP on message. So you don't want to have the 4 switch addresses here being used for anything on your railway, because it will confuse the pants out of all the devices. I don't know that Digitrax specifically tell people to avoid using these. Hey ho, let's have a look what else we've got on here. We've got signal switch addresses. And you might go, why does a signal have a specific switch address? The signals using the SIG M10 and SIG M20 boards from Signatrack, they normally float based on the next signal ahead, but you can force them to red. And you force them to red by applying, so for example, this black 1 signal, we can force to red by setting the switch 68, and that will lock it to red irrespective of whether the points are clearly set for it to be able to go out, and it would be showing green under normal circumstances. So these things change the state of the signal head from being floating to being restricted. And I think that concludes, oops, let's go and re-find what else we might have here. I think that might cover all the important signals. Oh, there's one here, which is the schedule switch responses. We talked about how we use sensor message to trigger train controller to run a schedule. And train controller sends out a switch message to help us to know that train controller has started a specific schedule. We haven't put we have got one here. So when train controller starts the schedule WA1 to green 91, it will send out this message with a thrown, and when it has completed the schedule, it will send out the same switch but with a closed. And that allows us our database system to know the state of all the train controller schedules whilst they're running, or if they're still running, or whether they have been completed or not. That concludes, I think, a quick update on the switches. The third database area I want to talk about is signals. Now, we've already talked about signals in terms of having the switches that force them to red, and each signal on the database has a status, and here you can see what is its current color status as recorded by the database from the LocaNet messages that the signals send out. If we'd sent one of those switch instructions out to black 01 to close it, it would have forced it to a red state. In fact, it's up there and it's held to red at present. Although it's held to red because black 4's got the path. Those 3 all go into the same track, so that's not the reasoning. That's all there is to really tell you about signals, but they're cosmetic on the railway. They don't physically do anything. They're following the trains, following the routes, following the blocks, following occupancy, and obeying instructions from train controller. But a red signal doesn't kill the track power or anything like that. That's all there is to say about signals. We have 210 of them, as you can see, signal heads on the layout. That's it for signals, I think. The fourth database that I want to talk about here is PCBs up here. The PCBs are all the different kinds of electronic boards that we have on the railway. In total, we have 283 of them at present, and that's still scheduled to grow. Some of the PCBs, like boosters, they're not all on here yet, and some of the PCBs, like the amp and voltmeters that we use from the RR amp meters that we use, aren't all on here either. So that will probably sail above 300 by the time that the layout is complete. Let's go and show you what else we've got in here. of all the different kinds of board types. Some of you are going to recognize these things. The BDLs, there's two versions of the BDLs. There's the DAC20, which controls the points. We have just one DCS 100. We have the DS44s, which control platform lights. We have the old DS54s, which predate the 64s, and we're currently using the DAC20s. We have the DTM16s, the DTM30s, the dots, the PM42s. We have the amp meters, the signaling boards, the sensor boards. We've also even put in every throttle socket on the layout so that we can keep track of our inventory. So if we were to search for the BDL 168s and also add a second search for the BDL 16s, you will see that we have 40 BDL boards. Each of those has 16 sensors. If I was to search for the DCS 100, hopefully we have just one. That's a relief, isn't it? If I was to search for the new Syn 16s, which is a prototype board that Fraser has developed, but allows us to have 16 sensor inputs, we have 20 of those on the layout. The important thing about each of these devices, so let me go and find a BDL 168. Let's just go in there. I'm going to go into one of these. What that does is have all the relevant information about the PCB that's relevant to the railway. So it links the sensors, the switches and the signals where appropriate to each and every board. So for a BDL, it only has sensors. But if we went back out again, and if I generalize the search collected all and scroll down, that's not going to be a good idea. It could be going on for a long way here, and found DAC20s. There we go. We have 28 of those. If I go into here, you can see there are no sensors with this particular DAC20, but there are all these switches on here. If I go to the next DAC20, this is the one in Manchester. There's some stock, there's a test unit, it's typical. There we go, this is Hades Island A, and you can see all the switch numbers down here. So this gives us a very complete picture of the world. And they link through to something else called panels, but I'm going to approach this from a different perspective in a minute. I think that concludes my quick summary on the PCBs. So it allows us, having the PCBs in the database allows us to make sense of where the sensors and the switches and the signals, what device they're attached to. And that's really important for the next section, which I'll cover in a minute. The database table I want to share with you is the panels here. We have 51 panels on this railway. But let me go and select just a subset of those, the Sheffield panels. And you might be thinking, what is he talking about? Here we have 6 panels associated with Sheffield. But if I go into the Sheffield power panel, it's all going to be very clear. This here, if I click on the view, we've embedded a photograph, and that shows us the drawer that is the Sheffield marshalling yard main power supply. There's the booster, there's the 2 PM42s, there's a stack of BDLs, there's some DAC20s. We even have an amp meter at the front here, and you can see all the BDL connections. So this is primarily the power with some point work in here. Let's close that. That's listed here, as you can see. Everything associated in this box here is in this list. And if I was to go in here and go to that BDL, I will then see all of the sensors attached to that sent to the BDL. If I go to this DAC20, I will then see all the points associated with that. This linkage works both ways. So from a missing switch, we can find what DAC20 it is. From the DAC20, we can find what panel it's on. And guess what? If we can't see what the problem is by going and looking at this panel ourselves, and having this photograph is a great aid memoir to identifying whether we've missed something or it's been wrongly assigned to a different panel. This really works well. We've also got the power supply connection. That's another crucial component because there are for Sheffield. This is the power for Sheffield, the switching yard. We next have the points board, because the old one wasn't big enough for all the points on Sheffield. The next one we have is, isn't that just great? I've gone the wrong way. Here we go, bear with me. Then there is, no, it's not going to show me. Don't know why. If I go into this PM42 list, it shows us that this particular power supply is driving two PM42s. And some power supplies directly drive dots, which is why there is also a list of sensor addresses here. So we can track down from a missing switch message, we can go and check whether the DAC20 or the DS54 is or is not working. By going to the panel, we know where it is. We can also then go to the power supply and see if that's got a problem. And it's all part of that interlinking of data to allow this to work really well because of the sheer scale of this railway. I think that probably covers the power supplies and the panels. Thanks for listening.